Okay, this is part 2. So now that our model is done, we see that our mean is about 1,401,000, which is around that. There's going to be a margin of error since it is a simulation, so it's close enough. And then we want to know the probability shall have less than 500,000. So what we can do is go down to probabilities and then do less than 500,000, and that's about 30%, which is close enough to this 0.29, so 29.7%. And the last one is if she increases the annual contribution to 6,000 per year, what would be the expected value? So what we would do here is run another simulation, but this time we would change the value to 6,000 rather than 5,000. I'm not going to go ahead and run that because for time's sake, I only have 5 minutes of free recording. So now we'll move on to this. If you want to diversify your portfolio, so you have different stocks or different bonds that have different return rates, you would want to allocate like a certain percentage. So your portfolio could be between 0 to 100% in terms of like the breakdown of stocks and bonds. So that's going to be different. So what we would do is, let me just delete all of this, and we're starting anew basically. So here we have the stock portion. Okay, so your stock mean and standard deviation. Your mean was mean return of 11.42. So let's change this to a percentage and then go 11.42, and then your standard deviation is 19.7. And then we'll do the same thing here with bond with the mean and the standard deviation. Change that to percentage. And then what you get is 5.18 and 7.76%. Okay, so now what we'll do is, okay, bond rate, stock rate is equal to normal distributed between mean that, standard deviation that, but what we want to do is also absolute reference that so that we can bring that all the way down. And then we'll do the same thing here, mean, standard deviation, and then we want to absolute reference that and then bring that all the way down. So now we want to do the bond return with allocation. Okay, so for our allocation, we stock, bond, let's say stock is 0, then your bond, okay, well this will actually be a percentage, so let's change those two cells to percentages, and let's say it's 100%. What you would equals 1 minus that, well technically it's 100 minus, wait, equals, no, hold on, sorry, 1 minus the percent. Okay, so what we can do is your bond return would equal the balance times the bond rate, but because that's the percentage of the balance, but then you also have to multiply it by your bond allocation, which in this case is 0. And then you do the same thing for stock return with allocation. In this case, you would do your stock times your stock rate times your new balance, which is equal to that. So what we can do is absolute reference this one, and then absolute reference this one, and then drag that one down and drag this one down. So now, as you can see, if we change this to 25, it'll change that. If we change it to 50, it'll change that. All the numbers will change. So now what we want to do, let me see, make sure how much time we have. Okay, I have a minute left. So sum. So this is our return. So we want to do the sum of this and the return of the bond and the new balance is equal to your new sum. But look, your beginning balance is not actually going to be that one anymore. It's now going to be this one. So drag that down, and then you want to drag this. Oops, no, we want, yeah, actually, that's right. Yeah, see? So all the way down here. So your new balance is that one. So I think my recording is about to end. I have 20 seconds left. But basically what you're looking at is this digit right there. So then I'll show you guys in another part 3 the simulation of what allocation would be best. Stock versus bond allocation from 0, 25, 50, 75 to 100.